AP problem, 2002, question 1. Let f and g be f of x equals e of x. Let g of x be ln x. These are inverse functions of each other. If I made a perfect graph, and I didn't, they would be reflected across the line y equals x. All right? An interesting side note. You don't even need this graph, but we should remember it for pre-calc. Find the area that enclosed between half and 1. Half and 1. They want this area. Okay? Yeah, they're going to want the decimal because you're going to have to use your calculator, guys. Oh, really? They take the fraction then. But I would just be, okay, hey, this is not hard, right? Upper curve minus lower curve from half to 1. Guys, that is worth a point, that integrand. If you type it in your calculator, I don't know the fraction because I don't have that type of calculator. Tell you what, do a decimal. Do a decimal on the AP. 1.222 something. 9. They gave credit for 1.222 and credit for 1.223. 2 points. All right. So that's letter A, everybody. And I might leave the graph here. I don't know what I need for B yet. All right. All right. So letter B now. I want to go through this. Find the volume of the solid generated when the region enclosed by the graphs F and G between the same two, all right, is revolved about the line y equals 4. So here's our line, not to scale. We're going to revolve the little yellow region about y equals 4. Guys, this is definitely not a cylindrical shell problem. Okay? This is definitely volume equals a to b, ax, dx.
What's the difference? How do you know the difference?
The difference for cylindrical shells or whether it's going around the old method is that in this case, you see y equals 4 is parallel to the x-axis, right? So you know that the old method would be a dx integration here, okay, to go about y equals 4. And in this case, again, let me ask you this, Sam. Can you solve for x in either of these problems easily? Not really. All right? So this is why it's the old method. And this is why you got to practice some of those in those sections so you can go back and forth. Everybody, is it a disc or is it a washer? That's where this it's washer. Awesome. All right, this is a washer. All right, and I would, again, I know it's overkill. I know it's overkill, but I always write it, right? And I say this every time we do it. I'm going to go 1/2 to 1 pi RO squared minus pi RI squared dx. And I'm going to bring out the pi. And a lot of times on the AP, guys, what I just wrote right here is worth a point. Just having the right pi and the limits of integration. I don't know. I can check here. Hang on. Limited constant. Yeah, that's worth a point this time. All right. I have RO squared minus RI squared dx. And I got to fill those in now. All right. Every time. All right. Every time. So I see that the RI is right there in red. I just made the arrow. So y plus RI has to equal 4. For RI is 4 minus y. Y equals, on the blue curve, e to the x. You guys agree? So I get RI is 4 minus e to the x. Of course, some students are always saying, Mr. Anderson, it's always subtraction. Yeah, but I like to do it that way. But I automatically know the other one then is going to be the same, but in this case just uses the other function, which is ln x. All right, this is definitely one I don't want to integrate by hand. I don't even want to think about it. This is why it's on the calculator section. So guys, I write this out, I type it in my calculator, and I get 23.609 is what they gave credit for. Okay, 23.609. Again, we go to the 4th decimal place because they credit for 3. Guys, this is 4 points this time. Limits and constant. Right there. That ugly stuff is a point. Okay? Each integrant, this is worth 2 points. If you got, all right? If you got one and not the other, you got 1 point. But it has to be RO squared minus RI squared. You don't get any. All right? And lastly, you get 23.609 as credit. All right? So 4 points. So think about this. For you guys getting ready for the AP, I would argue that we are on the AP test. This would not take you but a few minutes. You guys agree? These are the... All right? The x quantity squared. Make sure you get the brackets around it, guys. Yeah, that's a. I mean, that's 1/2 to 1. Make sure you get pi on the outside. Did you get 7.515 times pi? Times pi. 7.51. Nope, 23.609. I multiplied pi, and I used the pi key.
I don't see how it makes.
All right. Last one. Let h be the function. H of x equals f of x minus g of x. Okay, basically what we've been doing. You guys agree? Find the absolute minimum value of h of x on the closed interval 1/2 to 1, and find the absolute maximum value of h of x on the same interval. Show the analysis. All right, guys. We have a new function that's a difference, okay? We have to do the derivatives and check the endpoints, right? Guys, extreme value theorem. Because just doing the derivative, h prime of x will not be enough here, okay? We have to check the endpoints. So first thing I would do is write h prime of x. I'd probably write h of x equals e to the x minus ln x. And h prime of x equals e to the x minus 1 over x. You guys agree? And I want to know where h prime equals 0, right? In the interval. But I'll say h prime of x equals 0. And then where? At x equals. All right. I would just type this in my solver, guys. E to the x minus 1 over x equals 0. And I would guess 0.75, right? Right in the dead heart. All right? And what I get on my calculator from last year, because again, I've done these a lot of times. I get 0.5671. All right? Now, I don't know if that's a max or a min yet. All right? I don't know if that's a max or a min yet. I probably would do the second derivative to find out, okay? So that's my one critical point, guys. So it's either a max or a min, and I have my endpoints to check. I would probably personally do this. Take the second derivative, and what I see about h prime prime of 0.5671 is that it's greater than 0. So guys, this is a minimum. All right? This would be a minimum on that interval, right? Second derivative rule. Because the first derivative was 0, the second derivative was greater than 0, thus it's a minimum. All right, so now I know that that's a local min, probably the absolute min. I need to check the value of that and the value of 0.5 and 1 in the original equation h of x. So I need h of 0.5, right? And I need h of 0.5671. And I need h of 1. I have to, because we have a bounded, we're trying to find the absolute max and the absolute min of h of x. All right? Everybody, we have to check the critical point, which I know it's a min, and I have to check the endpoints. What I got for values when I type these in my calculator. And everybody, we're using this function for h of x, right? Let's not use the derivative by accident, one of the common mistakes. You got to go back to the original function. All right. So the absolute minimum this. Oops, I got the numbers screwed up.
Yeah,
I'm sorry. I
confused.
transposed two of them. Guys, when I was looking at my notes, 0.5 is 2.3418. I was about to say, wait a minute, the second derivative is lying. Well, I can't lie. How's that for better values? There we go. All right, everybody, it's what we said. 0.5671 is going to be the absolute min. The absolute min, guys, it didn't ask where, it said the value, right? So we got to write absolute min is not x equals, it's 2.330. Extreme value theorem, you got to check the endpoints. Got to check the endpoints. Yep, those are the endpoints on the interval 1/2 to 1. And the absolute max, or the global max, depending on the vocabulary, right, is this time, how about 2.718 at x equals 1? All right? Oh, that's nice. All right, so everybody, here we go. On the scoring, 3 points. Considers h prime of x is 0. Guess what? If you wrote that, you give yourself a point. You just wrote h prime of x equals 0. You get a point. Identifies the critical point and endpoint as candidates. Guys, right here. Even if you screwed up the math like I did before I fixed it, you get credit for that. And then lastly, you get a point for this. Guys, it said show to work. You know, I might even make a note here if I had time. I might even make a note. Must consider endpoints, right? If I could come back and make an additional note, that would be the note I'd want to put on here. Extreme value theorem, right? Must consider endpoints. All right, 9 points. All right, tomorrow, guys, make sure you finish 2004, right? All 6. Also, 2005 is on the internet for starting to review.